So today we're going to work through chapters 1 and 2. Again, these numbers out to the side over here are what chapter these are from. So we're going to start with our most favoritist of things, these pattern recognition things. So we're going to try and notice things that are the same and notice things that are changing. So what do we notice with this particular pattern? They all got 4 on the outside. So whatever's happening with the light blue piece, they've taken and added a +4 on the end. So that gets rid of the pink pieces. If this is figure 1, and this is figure 2, and this is figure 3.
And squared.
Yeah. This is 1 square. This is 2 by 2. This is 3 by 3. So whatever it is I can take this piece, the length of that side, and we're going to take it being our n, so that number squared. This one is 3 squared. This one is 2 squared. This one is 1 squared. So if we're asked to estimate the 65th figure, what are we going to do? 65 squared will give us our blue square inside, and then we add 4. So luckily we can use calculators for this, and we can do 65 squared, plus 4 is going to give us 4,229 squares in that figure. So it's looking for a pattern, and there's usually going to be different colors of shading. I know I don't get to use a color printer because, budgets. But there's usually different shading on it, and it will be very clear. And I'm not going to give you an obnoxious pattern like the tower one that we did in class back when we did this. It will be visually not awful to see. It'll be of a similar difficulty to notice the pattern as this one. Okay? So questions on our first one. Okay, so we'll do number 2 tomorrow because that's from chapter 4. Same thing, we'll do all of those ones tomorrow because that's chapter 3. That was chapter 5. That was chapter 5. There's not much from chapters 1 and 2. We always kind of love that. That's chapter 3. There we go, chapter 1. Woohoo, found one. Number 12. So this is a matching. We're going to match up the description with the expression. So this was when we were in our expressions thing. Nothing had equal signs. We were just kind of looking at pieces here. So we have both a visual piece here, and we have a couple of word thingies. So let's look in here. Let's look a little bit closer. What do we notice here?
Which one?
We are matching up A, B, and C with little a, little b, little c. C does go with C. 3 times x minus 2. 3 times x minus 2. So these guys go together. Yeah. So we can, my brain likes this one better, to do double a number and then reduce by 3. I'm going to double some number and then reduce by 3. Then I'm going to take away 3. So I see that as this one. And A is the most complicated. We've got double the difference of, so that means the difference is going to be in a set of parentheses. The square of a number, that's my x squared, and 3, that's this guy. So we're doubling this difference, is how I know that A goes with little b. Okay, so it's a matter of finding the teeny tiny pieces that match up. Number 13 is really similar. We're identifying equivalent expressions. So instead of it having the words that mean the same as the expression, we have two expressions here, and we're going to try and play match them up here. E with 3? B with 3. Yes, B does go with 3. Be more enunciative.
B as in dog.
Thank you. Because I heard B. Again, I was like, B can't go with all the things. So 4 has this 3 over 3. These are both going to cancel out to give me 1 over x. So it is exactly what we have for D. So on some of these, we may need to simplify.
A with 5.
A goes with 5. Again, we're simplifying, remembering our exponent rules here. We're multiplying this out. X cubed times x gives me x to the 4th.
E with 2.
You said E with 2?
C with 1.
And then C with 1. Yes, sir.
C with 1.
Yeah, y'all just are going faster than me, and I'm listening and trying to think it, because honestly, I haven't done this in a year. So yes, this one we distributed it out, and my E goes with 2. And then our last one is combining like terms. So 3x squared plus 6x squared gives me 9x squared. So there are going to be times when you simplify the left. There's going to be times when you simplify the right. There might be times when we have to simplify both and find that they simplify to the same thing. Because I could have written these in different ways. I could have done this one as 4 times 1/2 x minus 2. I could have written it like that. Nope, it would have been 1/4. It would have been exactly what I had on the other side. But so I could write, no, that one would fit. That one totally works. So I could write it like that, and it would still be that these guys match up. What's up?
When you're done with the unit 1 and 2 problems, can I finish that?
I can write your pass now.
I just wanted to wait a second.
Okay, that's fine. I also am recording it. Okay, so questions on either of those, because those are both from Unit 1 where we were looking at our expressions. Okay, so let's find our next one in Units 1 and 2. Number 15 is from Unit 2. This was our sometimes, always, or never. So always true means it's an identity, meaning it's, we use that word a lot, 2 equals 2. Something that is inherently math true. Always true. Doesn't matter what x is, doesn't matter what y is true. Thank you, dear. Sometimes true means it has a solution. It works when x is 3, but not any other time. So sometimes true gives you a thing like x equals 3, x equals 7. It only works when x has specific values. And never true means it is false. It is a straight up lie. 3 equals 0, something that is inherently false. So, looking at each of these equations here, because we're in equations now, not expressions. What do we think about A? Is this sometimes true, always true, or never true? Sometimes true. This is going to have a solution. I could solve and get x by itself. I could subtract 3 on both sides and get that x squared equals 9. I can see here that we are definitely going to be able to square root this and get x is positive 2 and x is negative 2. 2 solutions. That's fine. It's still sometimes. How about B? Always. Because if I distribute this out, we get that 3y plus 6 equals 3y plus 6.
Oh, I thought like you was substituting something.
We're not substituting. This is just distributing and then comparing. I could then, if we still didn't see it, which is totally fine, subtract 3y from both sides trying to get my y's together.
So you can't substitute.
We're not given two equations, so we're not really substituting. You could test it with values if you want to. Like plug in 3, plug in 2.
Yeah, is that not?
Yeah, I just didn't want us to think of substituting an equation because we've done that recently where we did our y equals and plugged the equation in. But yeah, you can absolutely test these with numbers. It's a little riskier then because our sometimes is we could accidentally hit those and think it was accidentally an always. So this isn't always, because if I subtract that 3y from both sides, we get that 6 equals 6. Which is always true. 6 always equals 6. My 3y's subtract out. So this one isn't always.
Never because I'm lazy.
Never because you're what?
I'm lazy.
Because you're lazy? Okay, I do need slightly more reasoning than I'm
You talking about
lazy.
the next one?
The next one.
It's always.
Let's find out.
If you-
How? Why?
Because like, say you multiply, you traded and you substitute the x for a 5, right?
Mm-hmm.
I mean for a 20, right?
Mhm.
You okay, 5 plus 7 equals 12, and then if you was to do 20 plus 24, 48 divided by 4 is 12.
So maybe it's a sometimes.
Why? But
I don't know.
You could do the same thing for like, say you substituted it for
Uh-huh.
12. You do 12 divided
Yeah.
by 3 plus 7 is 10, and then 12 plus 24 is 48. I mean 36 divided by 4.
Mm-hmm.
That's 12. Wait.
Is it?
Sometimes.
Let's see.
Good.
If we were not sure where to go, what could I do to make all the fractions go away?
Oh, multiply by 4.
Multiply everything by 4. When in doubt, get rid of your fractions. Like, don't make your life harder than you need to be. Take this guy by 4, take this guy by 4, take this guy by 4. Everybody. Because then this 4 and that 4 cancel out, and we're left with just 1x. Plus 4 times 7 is 28. And on this side, this 4 and that 4 cancel out, and we're left with x plus 24. Does that make it a little easier to see? Is this sometimes, always, or never?
Never.
JD, on when will those equal each other?
Not that, but like in a sense, where like you're not substituting.
You can, but you winding up accidentally finding things wrong because you also doing them in your head and making mistakes.
Because if you substitute, you can make them equal to each other.
When?
Look.
When?
Just listen to me.
I'm listening.
Can you write these steps out? Alright, do 1/4 times 20 plus 7.
That gives us 5 plus 7,
equals
12.
12. Right. Now, do 20 plus 24 divided by 4.
Mm-hmm. Which is
40
44 over 4, which is 11. Does 12 equal 11?
Yeah, no.
No.
I thought.
So all this would show us, if we started here, all this shows us is that it's not always. We can't from here tell if it is sometimes. I know. But that's okay. That's what we're here for. Okay, so all this proves is that it's not always. So we have to come on over here and kind of see here to notice that this is, in fact, never true. I could subtract my x's from each side, minus x on both sides, and get 28 equals 24. That is mathematical falsehood. 28 does not actually equal 24 ever. How about part D? What do we think on that one? Sometimes. We could solve this. For the most part, if you have an x on one side of your equation, it'll be a sometimes. It has to have x's on both sides for things to cancel out, or for y's on both sides for things to cancel out. So this one would be a sometimes. I don't know why that E looks like a C. There we go. All right, so this next one is a writing inequalities thing. So we're writing an equation and having it be an inequality. So this was like the very end of the chapter. So we've got that Jolie saving up money for a new iPhone 13 Pro. The new phone costs $999. She has $200 saved up from her birthday, and in order to make money, she plans to wash her neighbor's cars for $10 each. So how could we write an equation for how much money she's going to make if she has an unknown number of cars?
999 is equal to what?
So we know 999 is going to be our total.
Less than or equal to.
More than.
Let's see. We'll think about it. I'm going to put equals for now, and we'll think about which inequality it's going to be, okay?
Alright, 10x.
So 10 times each number of cars. So 10x or 10c, doesn't matter because $10 for every car
Plus 200.
plus the 200 she has saved up. Questions on this part of the equation before we do the inequality part? So if she wants to have enough money to buy the car or buy the phone and some accessories, which side needs to be bigger? The left or the right? The right. If this side needs to be bigger, make the alligator eat the bigger side. So it'll be less than or equal to. Because she'd be fine exactly being fine. Like, she can get the phone with no accessories. It's fine.
Can you run it the other way though, right?
If I write it this way,
No, yeah, because I was doing like 10x plus 200.
if you flip the whole equation, that's absolutely fine. You can do 10x plus 200 is greater than or equal to 999. That's absolutely fine. It's still alligator eating the bigger side. There is no shame in using the alligator as a tool. I have a friend who is a literal rocket science. She works at the Rolls-Royce Aerospace Engineering Department. Like, she's a literal rocket scientist. And I asked her at one point, do you ever still think about the alligator with inequalities? And she said, absolutely every time. She is a literal rocket scientist. So, just saying, just because a tool is childish does not mean it is not still valid or good. She is a no-joke rocket scientist. All right, let's see what else we got going on here. That's chapter 3. This is chapter 4 and 7, and I just totally drew a line down that page, and now it froze. Love that. So much fun. Okay, it'll let me draw a line. There we go. No, let me zoom. There we go. Okay, so that page is 3, 4, and 7. That page is 7. That page is 3 and 6, and that's the end. So that is everything from chapters 1 and 2. So we do also have reviews up on Canvas. So if you want to go further and practice chapters 1 and chapter 2 on Canvas, there are some reviews that have very similar questions that let you practice through this again. Okay? The reason I have it split into 2 chapters like this is so that any one day is not incredibly overwhelming with the amount of things we need to do.
It's my name.
Yeah, because I will often take my old class rosters and cycle through names with that, so it probably was actually you when I wrote it the first time. To be fair, there's a lot of names in here. And you on the very last question. Just saying.
Best for last.
But that's whenever I'm updating story problems, I always just pull a different class that's not one of my classes that's currently enrolled in it. And this is genuinely the first time it's ever happened where I haven't caught it and updated the name so it wasn't their name in class. That you are a little bit of chaos?
No, it's totally 100% peaceful, and I'll make your day every day by sticking with it.
That you are chaos is what I'm going to stick with. All right. So for the rest of this time, work on paper review, work on Canvas review, ask questions. The finals over everything from the whole year. The multiple choice is going to be on Monday, and the short answer is going to be during our 7th period final exam time on Thursday. So that's kind of the vibe. Woohoo!